Hey guys, it's Coach Tapman, and today we're going to be talking about efficiency. So, what is efficiency? Well, efficiency is closely related to mechanical advantage. Mechanical efficiency is a dimensionless number that measures the effectiveness of a machine in transforming the power input to the device to power output. And so, really, a way to think about it is it's like a percentage that tells you how effective something is at being ideal. And so, another way of thinking about it is the ratio of the actual mechanical advantage to the ideal mechanical advantage. And so the reason you have to consider efficiency is for things like friction losses, heat losses, head losses, and things like that occur in the real world outside of the idealized. And so some examples of efficiency, you see efficiency in heat transfer whenever you're talking about the efficiency at something being able to perfectly conduct and transfer heat through itself without losing heat to the outside environment. Energy transfer, again, heat is a big one. Pressure also associated with it. You see it in simple machines like we're going to be talking about. You see it in fluid flow, the efficiency of something being able to transfer a fluid with perfectly pressurized fluid the entire way. Electricity often loses energy due to heat being lost through whatever conducting vessel it is in. And so efficiency is all over, and it's really important. And a really simple way to consider it in a very low graphics, poor quality image is just this equation here. So it's going to be nu is equal to power output over power input. And so efficiency, again, fairly straightforward and simple, but really important mechanical advantage. And the work that we're going to be doing, we're going to be figuring out the efficiency by solving for our mechanical advantage and solving for our ideal mechanical advantage and finding the ratio between the two of them. Now we're going to look at a quick fun little example of efficiency using a wheel and axle in mechanical advantage. So first, the children's rhyme. Jack and Jill went up the hill to fetch a pail of water. At the well, Jill used a clockwise force of 20 newtons to turn the crank handle of radius 0.4 meters to rotate the axle of radius 0.1 meters so she could raise the 60 Newton bucket of water. First question is, what is the ideal mechanical advantage of the wheel? Well, we know the ideal mechanical advantage of a wheel is equal to the length of our effort arm divided by the length of our resistance arm. And we know the length of our effort arm from the problem statement is equal to 0.4 meters. We also know the length of our resistance arm is equal to 0.1 meters. If we plug that into our equation, we know the ideal mechanical advantage then is equal to 0.4 meters over 0.1 meters, which, doing some quick division, gives us an ideal mechanical advantage of 4. Okay, well that's great. That's very useful. Now, what is the actual mechanical advantage of the wheel? Well, fortunately, we were also given the input force and the output force that Joe was able to achieve using this wheel and axle system. And because mechanical advantage is equal to your output over your input, we know that this is going to be equal to our true resistance force divided by our effort force. And we know that Jill applied a force of 20 newtons. And the resistance, or the load, was 60 newtons. We know the mechanical advantage then would be summed up as 3. Okay, so we're able to calculate our true mechanical advantage and our ideal mechanical advantage. Now, what is the efficiency of the wheel? Well, for some reason, the ideal mechanical advantage of 4 wasn't achieved. Jill had to apply more force than the 15 newtons it would take if the ideal mechanical advantage was accurate for the system. So there was losses somewhere along the way. And my prediction is it was likely due to friction. Most most wells weren't built thinking of perfect lubrication and a frictionless system. And so, the way that we're able to calculate efficiency then, efficiency is equal to our actual over ideal. And we know already that our actual mechanical advantage is 3 and our ideal is 4. Meaning we have an efficiency of 0.75 or 75%. And so just using this example problem, we're able to see the way that we can appreciate efficiency is telling us how effective is a system at providing an ideal mechanical advantage. If you guys have any questions, as always, please leave them in the comments below. But thank you so much, and we'll see you in the next video. Bye, guys.